Moving a lot closer to home, the universe's youngest asteroid, I think, possibly the solar system, as Terry said before we went live on air. This is a good story as well. So in the past, I've done a lot of work picking up new asteroids when I was working with the Fox telescope, which are 2 meter telescopes, one based in Hawaii, one based in Haleakala in Hawaii, and the other one at Siding Spring in Australia. And we used to do a lot of observations and picked up a load of new asteroids, and it's really fun finding a new asteroid. These two were detected in 2019 by a combination of the Pan-STARRS survey in Hawaii, which is one of the big wide field sky surveys, and the Catalina sky survey, which people like Jim Scotty and loads of people, Carl Hergenrother, etc., all work over at Catalina in Arizona. Fantastic facility, and they do lots and lots of wide field surveys. And it was amusing talking to Jim Scotty once about this, and him saying, when I was thrilled to have found one asteroid in a night, and he said, "Oh yeah, we found 60 last night," kind of thing. It's crazy, but these two. So this is 2019 PR2 and 2019 QR6. So two asteroids, basically it's a binary pair, and one of them is about 0.6 of a mile across, the other one's about 0.3 of a mile across, and they're kind of doing their kind of orbital dance around each other, and they're quite interesting in their own respect. But what's really interesting about these is that, based upon the spectroscopic data that's come from them and some of the observations in terms of, from the ground, obviously, you're only going to get very, very limited details in terms of optical shape characteristics. You're not going to get much. Arecibo's radar, as it was when it was operational, sadly, before the big catastrophic accident there, that was able to do pretty good radar detections. If you had asteroids within a few hundreds of thousands or millions of kilometers of the Earth, they could bounce a radar off it and get a pretty good shape. We don't have really that kind of capability until the Square Kilometre Array. Maybe the Chinese radio telescope, the 500-meter telescope in China, could do some pretty good observations, but we don't really have as good a radar capability anymore. So the light curves from these, you can infer the rotation rate, you can see the different asteroids and how they're rotating around each other. What's really interesting with this is that it's believed, and I'm still quite skeptical about this, that the material that's covering the surface, they've kind of identified it as being really fresh material, like so fresh that they think that these small asteroids separated from their parent body only a matter of about 270 years ago, 270 to 300 years ago. This is the estimate. Now, that sounds all well, because we get asteroid collisions all the time, and you get impacts, and this is why things change orbit, etc. It's one of the potential theories for the Tunguska explosion in 1908 over Siberia, which was theorized that a fragment of Comet 2P Encke had basically separated at some point in its orbit and then slammed into the Earth and airburst and caused the devastation over Tunguska just over 100 years ago. But what they're saying with these two is that they think they've separated from a cometary parent body. Now, this is where my kind of because you look at the mass and the the H value, the kind of absolute magnitude, etc., of these objects, and you especially the mass, and you can infer the mass from the rotation rate, etc. Cometary bodies tend to have a very, very different composition to most asteroids I'm aware of. I've got a massive collection of like meteorites behind me in the cabinets, and they tend to be iron, stony iron, or stone in their composition. You can get rubble pile asteroids. Obviously, we had the OSIRIS-REx mission where it kind of plunged in, it picked up a load of detritus from the surface as well. So you can get the kind of softer composition asteroids. But I don't know, Terry, thoughts on this? They're really interesting, and the fact that we're not going to be able to get a really detailed set of observations now because of the nature of the orbit until about 2033. It's one of those things that, is it wait and see, or if it is this interesting and potentially they are that fresh, then we utilize some of the launch capabilities offered by companies like SpaceX to send small flyby probes, something that could do maybe a closer up inspection, maybe get more detailed observations on it up close if the scientific value of this is as high as they say. That's just my kind of take on it. Thoughts, Terry?
Yeah, I would also have slight doubts about them coming from a comet. For them to be that size and to have been, separated from the parent body, presumably it would have been considerably bigger. And unless it was a totally dead comet, we would probably have some record of it. We know of the orbits of most of the comets in the solar system pretty well. And if it only occurred about, say, 1750, roughly in year terms, that's not that long ago. It should be possible to trace back their orbits and see if they intersect with anything that's either a known comet or a known asteroid. Because the other thing is that it may not have been rotational fission. It could possibly have been a slight impact on a rubble type body. And that would have then separated a couple of them from the larger mass of the body. But we just don't know enough. As you say, in 2033, they'll be coming back for a pretty close approach to the Earth, and we'll get a much better view of it then. But yeah, I would be quite suspicious about a comet being able to spawn off two bodies of that size without it being a comet big enough that we would already know about it. I do have some doubts about that.
I mean, it's not unheard of. Again, using the Folks, we used to observe cometary separation and fragmentation events all the time. There was
the Ellis comet
on that. Yeah, 213P was a classic where there were like 8 chunks came off that the size of Mount Everest. It's not unheard of. As you said, these are quite large bodies, though. On saying that, some of the comets that have been observed recently are huge. So it's not unfeasible, but I think it needs one of these close-up scientific approaches. And I think waiting until 2033, yes, we could get better ground-based observational data. There's obviously going to be much better telescopes available by then, Vera Rubin, EELT, etc. There's going to be a lot more that we can do. Obviously, with the James Webb going up, this could potentially be a target if its solar incident kind of distance isn't too close, as it were, then potentially the Hubble or the JWST could even do a spectroscopy on it and try and get more data on it. I don't know. Very interesting, though. I love this. This was a great find. Thank you, Terry. Such a real passionate subject of mine.